Hello everyone, today we will take a look at linear equation or problems looking at graphs here. So Archimedes drained the water in his tub. The amount of water left in the tub in liters as a function of time in minutes is graphed. So as you can see, right, in 1 minute, it's drained about this much. We don't know what exactly that point is, right? Because we're not given the specifics of that because it's not in the corner of a square. But it seems like this one is. So in 2.5 minutes, it's drained about 180 liters. And then about 5 minutes, there are no more water left in the tub, right? And then initially at the 0th minute, starting point was 360 liters. Okay, so let's take a look at what it's asking. How fast did the water drain, okay? Well, as you can see, the water is draining at a constant rate. Okay, this rate is not changing, but we don't know what exactly that rate is. So why don't we take a look? Remember, we want to choose 2 points that are on the box, on the corner of a box. I know that that point is in the corner of a box, and that point is in the corner of a box, and that point in the corner of a box, right? I don't really like to work with 2.5, right? Decimals. You can if you want to, it doesn't really matter. But I got this point here and this point here, and they seem pretty satisfactory to me. So this one is 0 and 360. So in 0 minutes, there are 360 liters. And then in 5 minutes, there are 0 liters, right? So let's take a look, right? This is my y, this is my x, this is my y. This is my x, this is my y. So how much did it change, right? It went from 360 to 0, okay? 360 to 0. If you look at the difference between 360 to 0, well, it's, you know, it lost 360 liters, did it not? So it was at 360. How do we go from 360 to 0? We lose 360, which is the same thing as negative 360, right? And then how much time has passed from 0 minutes to 5 minutes? So we lost 360 liters. And how much time has passed? 5 minutes, right? 0 minutes to 5 minutes. That's that, right? And so that's 5 minutes, okay? So let's do 360 divided by 5. 360 divided by 5. And then we got 72. So if we divide the numerator, if I divide the numerator and the denominator by 5, then that's going to be 360 divided by 5, which is, we said, was 72 over 1 minute. Okay, so 72 liters per 1 minute. Okay, so that is our slope. That is how fast did the water drain. The water drains 72 liters per 1 minute. Okay, so 72 liters per 1 minute. Okay, and then that seems good. All right, let's try this one. How long did it take the battery to completely charge? So let's take a look at this one. Okay, so battery is charged. The percentage of the battery capacity that is charged as a function of time in minutes is graphed. So let's take a look, okay? So we're trying to find the slope because we want to see how fast the battery charges. So as you can see, there's a lot of different points that are on the box, right? We can choose any on the corner of the box. We can choose any of these points, right? Because they're all in the corner of the box, okay? But to make things easier, I'm going to, I don't know, let's just choose this last one. I don't have to, but I can. So 30 minutes. In 30 minutes, 100% is charged, okay? And then in the beginning, in 0 minutes, it had 40% charged, right? So how do we check, right? How did it go from 100 to 40 or 40 to 100, okay? The way that we check, right, the difference or the change that went from 100 to 40 to 100, we just subtract the two numbers. So we got 100 minus 40, 100 minus 40, and that gives us 60, right? So the change in the percentage of battery, right, went from 40 to 100. And this is my y, and this is my x. And my y has to do with the capacity of charged, and x represents time. So it went from 40 to 100%, which is 60%. difference. And then how much time has passed? The time has passed from 0 to 30 minutes. So 0 to 30 minutes. How much time has passed from 0 to 30 minutes? Well, 30 minutes has passed, right? So then if we divide the numerator by 30, the denominator by 30, 60 divided by 30, 30 is 2%. And then 30 minute divided by 30, 30 divided by 30 is 1, which is 1 minute. And that's going to be 2% per minute. How long did it, oh, whoops. They're actually not asking for the slope, right? Well, the slope, if you wanted to find out, will be 2% per 1 minute. But the question that it's asking is, how long did it take the battery to completely charge? Okay, well, let's take a look. Let's take a look over here. To take it completely charged, I'm gonna move it up a little bit more. Okay, it's right here, right? In 30 minutes, it was 100%, right? So at 30 minutes it was 100%. So the answer is 30 minutes. 30 minutes. And then we check it, and we're good to go. Yep, that's it. So let's try again one more time. Okay. Okay. So let's take a look at this one. Suraj took a slice of pizza from the freezer and put it in the oven. Okay. The pizza's temperature in degrees Celsius as a function of time in minutes is graphed. So this right here, as you can see, the pizza was like, I don't know, -7 degrees or something, -6 or -7, and then it increases, and by the time it hits like 3.25 minutes is in 20 degrees Celsius. So it's a pretty complicated graph here, but not complicated, but uses decimals here. So how long was each increase by 4 degrees Celsius? Okay. So let's take a look. Okay. So how long was each increase by 4 degrees Celsius? So why don't we just choose, find the slope first. Okay. Let's find the slope first. So what I'm going to do is I'm going to choose 2 points that I want to work with. Okay. So I'm going to choose this point right here, and because that's in the corner box, I can choose this point right here. I can choose that point right there, but that point, the decimals is a little bit weird. It's actually right there is 3.25. Okay, but that's a little bit weird, so I'm not going to choose that point. I'm going to choose another point like F. Let's choose this point. Okay, and that right there is at 4.5. And this right there is at 2, okay? So that point is going to be 210, and this point is going to be 4.5 and 30, okay? So this is 210, and then this is going to be 4.5, 30, right? So let's go and see the temperature. So this is the temperature, my y. That's my y, x. That's my y and x. So how much temperature change has happened from 10 to 30? Okay. The way that we find any change is we just subtract the two numbers. So 30 minus 10 is 20, right? So 20 degrees Celsius has changed. Over, right? Remember, rise over run. And then my run, or how much time has passed, right? Time has passed from 4.5 minutes to 2 minutes, okay? If you want to see how much time has passed from 2 minutes to 4.5, we just subtract the 2. So we do 4.5 minus 2, and it's going to come out to 2.5 minutes, okay? So they're asking how long was each increase by 4 degrees Celsius. So we want to get this 20 degrees to 4 degrees Celsius, right? So how do we do that, right? We have to divide the top and bottom by 4, right? 5, right? So watch this. If I divide the numerator by 5 and the denominator by 5. 20 divided by 5, 20 divided by 5 is 4. So that's going to be 4 degrees Celsius over 2.5 divided by 5. That's going to be 0.5 minutes. So in order to raise 4 degrees Celsius, it has to spend 0.5 minutes, which is 30 seconds, right? And so that is that. And so also I wanted to show you guys this rise right here. This rise right there is 20, right? From 10 to, oh, it's supposed to be, oops, yeah, is 20, right? From 10 to 30 is 20, right? My rise. And my run is from 2 to 4.5, which is 2.5. So my run is 2.5. My rise is 20 degrees. And so 4 degrees over 0.5 minutes. So every 4 degrees Celsius increase by 0.5 minutes has passed. So 0.5 minutes. 0.5 minutes is the same thing as a half a minute. And we're good. All right, let's take a look at this one. So how high was the plane after 1,000 seconds? So if you guys take a look, this is the height, this is the time. So in time, 1,000 seconds, it was about 3,500, right? Because right between 3,000 and 4,000 is 3,500. So it's going to be 3,500, 3,500 off the ground, and we're good to go. All right, we want to find how her weekly profit as a function of graph, amount of paprika sold that week. That's interesting. I don't know what paprika is, but we want to find the slope here, right? We want to see how much money she sells per kilogram, right? So let's take a look. So we want to just choose any 2 points that are on the graph on the corner of the box. I'm going to choose this one. And then I can choose that one. Right? I don't have to, but I chose to. So that's going to be 35. I'm going to do this like this. 35, 0. And that's going to be 60, 200, right? So that's going to be 35, 0, because right between 30 and 40 is 35. And the y coordinate is 0. And the x coordinate is 60. And the y coordinate is 200, okay? So let's go find the rise. The rise is going to be from 0 to 200, right? So what is the difference from 0 to 200? It is 200. So that's my rise, which is my dollars. And then what's my run? My run is from 35 to 60. Okay, how do I find the difference between 35 to 60? Okay, 35 to 60, we just do 60 minus 35, and that gives us 25. So this rise is $200. And this run is 25 kilograms. So that's kilograms, okay? So we're going to divide the numerator and the denominator by 25, like that. And that's going to be 200 divided by 25. That's going to give us $8. And then 25 divided by 25 is just 1 kilogram. So it's going to be $8 over 1 kilogram. So $8 per kilogram, and we're good. All right, so I hope that helped, and I'll see you guys in the next video. Okay, bye-bye.